afternoon, everyone. It is meaningful to interact with researchers in various fields. The title on my paper today is Design of Potato Classifier for the Mechanization of Potato Harvesting. The authors first and the third is from university, and the second one is from industry. We collaborated the school and industry. The contents is from introduction to conclusions. The background of this study is the decrease of farming population aging. In the light of the aging rate of rural areas, field farming will be impossible without machines in the next 10 years. From the population of a farming household drops and continues to decline. Because of the aging population, it is considered very important to serve manpower shortage as well as reduce the time required for existing potato harvester. In this study, classifiers were mainly examined. Method of size classification according to the potato specifications. Table shows the Korean potato size from X large to SS, while in the United States, the potato classification is by diameter, maximum diameter and minimum diameter and weight. The trends can be obtained as shown in the figure. We purchased potatoes from the market and measured the size and weight. This figure shows the conceptual design of the classifier. The principle of potato classifier is that the diggers digs potatoes from the soil, and it separates potatoes from soil and turn into the classifier. The classifier classifies the potatoes from small size to X large size. The design was made using conveyor belts to classify potatoes into classifier by size through digger. The length of conveyor belt was 1 meter. The diameter of smallest potato and the largest potato was obtained to calculate the gap between the outlet. Two conveyor belts are required to transport potatoes by means of a conveyor belt. It is very important because the width and the slope between these belts must be the appropriate value for the potato to be transported smoothly. The power of conveyor system was expressed in the following manner. The power of conveyor belt system, here V, the design speed was calculated as the following equation, and the TE, the effective tension must be known, and it was obtained using the following formula. So the power of the conveyor system was calculated as like this. In order to select motors, watt must be obtained using the power transfer efficiency of each component. The following equation is used to obtain power by using efficiency of each component, and the result of calculating the power required to select motor is 80 watts. This figure shows the classifier design, and this shows the production of classifier according to the design. The feed rate of the belt was measured according to the rotational speed of the motor. The classification performance was tested on how accurately the produced classifier classifies without damaging the potatoes. The result was shown as shown in the figure. Potato sample was counted and the average weight was measured as shown in the table, and the classification rate was obtained like this. Discussion. A lower classification rate was derived than the target rate. The problem seems to be caused by the irregular shape of the potato and the short track length of the conveyor system. To compensate for this, it is necessary to find a way to shorten the spread angle by lengthening the conveyor track to reduce the overlapping error range for each size criterion and to minimize the current conveyor system. Conclusions. Major conclusions are as follows. Potatoes can be sorted by size at the same time as they were excavated. And the speed of the motor that can be classified without damage is below 900 RPM. As a result of the design and the manufacture of the classifier, the classification rate was obtained for small, medium, and large respectively. If potatoes are well-shaped, they can show a higher classification rate. Thank you for your attention.
Yes, thank you so much, sir, for your presentation. So do we have any questions for GJ Kang, sir?
Yes.
Yeah, Mr. Khan, I just wanted to ask, like, have you made any design for this and also any mechanism study for it? What mechanism you would like to suggest, or what is the current mechanism and what is the proposed mechanism? When you tell design, so what is the engineering design? I mean, are you talking about product design or engineering design? What design?
Yes. To sort the potatoes from small size to large size, I introduced the mechanism of using conveyor belt.
Okay, have you made any design with any of the software and mechanism study on this?
Oh,
Yeah,
I didn't use the software. This mechanism is only carried by mechanically.
Okay, okay. Understood. So because if you would have made some demonstrations of using CATIA or any other software like Creo or SolidWorks, Unigraphics, the representation of the mechanism design would have been much more value added for the and it would have been much more very nice with respect to how mechanism happens and simulation happens and whether this design what you have proposed will it work or not. So all those things we could have, you could have taken up, I believe.
Yeah, okay, I see.
Yeah, good one, good work, thank you.
Oh, thanks.
Thank you, Ravi Kumar, sir, and thank you, GJ Kang, for your
Yes.
presentation.